Okay, so in this video, we're going to dive more into specifically the types of probability. So there are two main types. The first one is experimental, which you could probably guess from the name, is the probability. So it's probability that is determined. So the probability that's determined, spelled that word wrong, sorry, by the results of an experiment. So again, it's the probability, and that's determined by the results of an experiment or a trial. So there's a fraction that we use here, and it's the number of successes. Successes over the number of trials. And we'll talk about what a trial is in a moment. The other main type of probability is theoretical. Okay, so that's a mathematical way to determine. So a mathematical way. To determine the probability of an event. When we say event, we really mean something happening. Okay, and normally we write this as using P and parentheses with whatever the event we're talking about in the middle. So, and that can be written as the number of favorable outcomes. So the number of favorable outcomes over the number of possible outcomes. Okay. And this is all simple probability. Another thing we need to know is what a trial means from up here. So what exactly does a trial mean? So it's a single performance. So a single performance of a probability experiment. So if I'm saying I want to find the experimental probability of us rolling a dice 30 times. Each time I roll the dice, that's a trial. So if I want to do it for 30 times, then there's technically 30 trials to that experiment. So if that kind of puts it into perspective. So let's think a little bit out here. So let's think, what's the probability of flipping a coin and landing on tails? Okay, so how many outcomes are there on a coin? There's heads and tails. So there's 2 outcomes, and tails is one of those outcomes. So do you think this is experimental or theoretical probability? If you said theoretical, you'd be correct. So this is theoretical probability. Now this next one, I flip a coin 20 times. Of those 20 times, it lands on tails 9 times. So because we're doing this a whole bunch of times, that makes it experimental. And my experimental probability of it landing on tails is 9 out of 20. because of the 20 times of the 20 trials, 9 of those were successful and landed on tails. Okay, so that's 9 out of 20. Okay, if theoretical and experimental probabilities are for the same event, it's often that they're not the same, right? So up here, we said that theoretical should have been 1/2. So in theory, there should have been 10 out of 20 that landed on tails. But in reality, in our experiment, only 9 times did it land on tails. Okay? And that's all right. Okay? And that's because theoretical is the probability that an event should happen. So big letters here, should. That an event should happen. Whereas experimental is what did happen. Or, yes, what did happen. All right, so now let's put this into practice. Let's put this into practice. All right, so looking at this spinner, we want to find the theoretical probability. So the first thing we need to do is find the total number of outcomes. So what that means is how many different options do we have on the spinner? Okay, so there's 8 outcomes. There's 8 outcomes. So I want to find the theoretical probability of spinning a 2. So how many 2s do you see? How many 2s do you see? I see 1 2. So then the probability of me spinning a 2 is 1 of 8. What about even numbers? How many even numbers do you see? Well, I see a 2, a 4, a 6, and an 8. So I see 4 even numbers out of the total of 8 outcomes. Now, I'm looking at 4/8, and I know that that's a fraction that can be simplified. So you always want to simplify your fractions. So always simplify those to 1/2. We could simplify that too. Okay. What about spinning a 5 or a 7? Okay. I see a 5 here. And I see a 7 here. I don't see any other ones. So that's 2 8s, which again can be simplified to 1/4. What's the probability of spinning a 2, a 4, or a 6? A 2, a 4, or a 6 is 3/8. Okay. How many times would you expect to land on a 2 or a 3 if we spun the spinner 8 times? So how many times would I expect to land on a 2 or a 3 if I spin the spinner 8 times? I would expect to land on it twice, 1 for each. Right? Because of the 8 times, I'm probably expecting to land on 1, 2, 3, 4, 5, 6, 7, 8 in some order. I wouldn't expect it to do doubles because we have 8 outcomes. So in theory, it should land on a different one most of the time. Okay, well, let's look at the next one. So, sorry. What's a little different here is that this one has colors and numbers. They don't use them at the same time. So it's either talking about the colors or the numbers separately. Okay? So looking at this, what's the probability that the spinner stops on red? Okay, before I do that, I have to figure out how many outcomes are there? What's the number of outcomes? So all right, so the number of outcomes, 1, 2, 3, 4, 5, 6, 7, 8. So there's total of 8 outcomes. So that's going to be the bottom of my fraction. Now, what's the probability it's going to land on a red? Okay, so we have to figure out how many reds there are. There's 1 red, 2 reds, 3 reds. Okay, so my probability is then 3/8. Okay, what's the probability that the spinner lands on a color other than blue? So another way to say that is not blue. So we want every color but blue. So that means I want red and green and yellow and red and green and yellow and red. So that's 7 out of the 8 options that don't land on blue. Okay. We also want the next one is a number greater than 10. So I want to look at the numbers and figure out how many are greater than 10. So I want you to look at the numbers and figure out how many are greater than 10. Hopefully you're thinking all of them are greater than 10. So that's an 8 out of an 8 chance. Or if you simplify that 1 to 1, or simplify that even further, a 1. Or if I know that it has 100% chance of happening, then that's certain. It is certain to happen. Okay, so all different ways. If I were to write this fraction, I would write it as just 1, to be honest. Okay, you spin the spinner 20 times, it stops on green twice. What's the experimental probability of it stopping on green? Okay, so experimental probability is the successful times over the number of trials. We spun the spinner 20 times. That's the number of trials. How many times did it stop on green? In the sentence, it says it stops on green twice. And then we just simplify that fraction to 1/10. Okay, so the next two are your homework.